Hey everybody, hope everybody's doing all right. This is the welcome to week 15, the final week in the semester. Last week we started getting into an introduction to linear regressions, and really what I wanted y'all to do for last week, I know there wasn't much work, but I really wanted y'all to see that you can calculate a bivariate regression model by hand, just to see that it's possible to do so, right? And by bivariate, it's just two variables. So regression goes a lot further. It gets into multiple variables or multiple regression. Um, and I just wanted y'all to get a good look and feel for it and see that it is possible to calculate that by hand. Calculate the intercept, calculate your slopes, and this is the intercept, and this is the equation itself. You know, and calculate those values. And I also showed y'all a video on how to calculate R squared by hand. I didn't necessarily need to ask y'all to do that or want y'all to calculate all that and do all those calculations. It's good for those who did decide to do that, but it's good to see how it all plays out, at least in my mind, and get y'all a little bit involved in seeing what's going on with that. But essentially what the regression model does, it's looking at how one variable affects another, right? And these are essentially the results from last week in the calculations by doing it by hand, and how you could get there, and how you can get to how you can figure out how days in the rehabilitation facility might affect days an individual uses marijuana 1 year after. And this is accounting for all the conditions, right? The fact that they were in rehab for so many days, and the amount of days that they would report using marijuana in the year following being admitted to a rehabilitation facility. So beyond all that, I really just want y'all to grasp some simplistic concepts. Well, not, I guess it's not that simplistic. Want y'all to have enough information actually to get yourselves in trouble. And maybe y'all can take this information and move forward with it. And certainly, you can apply this, just a bivariate regression model in your daily lives, or if you're doing your master's thesis, or if you decide to go on to work on your PhD or something to that degree, right? Essentially, this is kind of what the equation looks like, and here's one of the answers. For one of the questions, it says write the regression equation below with the correct values used in the names for the variables in columns B and C, right? So this is kind of how it looks. So days that an individual uses marijuana, it equals 17.25, which is the intercept, minus 0.3 times the days in rehab. Now, that might seem complicated or seem convoluted. That's why I kind of added this extra credit. So hopefully some of y'all try to attempt to do the scatter plot and integrate a trend line here, but this is what we would call a regression line. If you figured out how to do the trend line itself, much more bonus points for y'all. But essentially, this is kind of how the relationship looks, right? So for every days in rehab being the x-axis, days using marijuana being the y-axis, this is 1 year after. You can see as days increases, the likelihood of marijuana decreases. How much does it decrease? Well, on average, it increases by 0.03 by each day a person spends in rehab. So simply put, after 10 days, 10 times 0.03, 10 times 0.03 is 3, right? That minus 17 after 10 days, the average would be 14.25. And then after 20, it would be another minus 3 from there. Does that make sense? 20 times 0.03 would 6. It would be 11.25, right? And that would be here. And that's why you can see it continue to go down. Now, it's important. The intercept itself right here, the 17.25, that's what this is. This is the estimate of the regression intercept when the other values are set to 0. All right, This equation is lacking though. All right, this equation doesn't account for the error term, and it's only a simplistic bivariate regression model. But simply put, hopefully y'all can see that, right? So as every day increases, uh, the days using marijuana decreases by 0.03, by 0.3 on average, okay? And it's not accounting for the error term because there's errors in prediction and all that type of stuff. But as you can see, once you get to about close to 60 days here, the expected average use of marijuana is going to be 0. All right, because people spent 60 days in rehab, and for whatever reason, at this point, marijuana use is substantially declined to that degree. Okay, now seeing all that, what we're going to do for this week is kind of work on interpreting. Okay, work on interpretations. Um, uh, and actually, we're going to utilize the same data set, and I'm going to get y'all working through on this, and I'll show you kind of what I want y'all to do right here. So you go to data analysis under the data tab here and click the regression, right? So here we have our input Y range, and this is the Y, right? Days using marijuana after rehab. That's that. Now the X one, we'll click on days spent in a rehab facility. That's the cause. I'm going to click labels here because I scrolled through both of them, okay? The confidence level, we want to set that at 95%, so that's at 0.05, right? And the output range, we want to place that right about here, I think, okay? And for completeness, I want to put this line fit plots, okay? And let it run, all right? Now, these are basically the same types of results I'm going to have here. Well, my calculations are a little off from the intercept there. But day spent in rehab, negative 0.3, right? And so every increase in a day spent in rehab, we expect marijuana use to decrease by 0.3, right? And starting from 17. And that's on average, okay? These are things I didn't necessarily talk about last time, but I kind of want y'all to be able to interpret it and explain. I'm not going to really talk too much about the multiple R, but it's important that y'all understand what the R square is, okay, when you're looking at regression models. What this does is it's the explain variance, okay? It's the explain variance by the regression line. It's explaining how much of a disparity exists here, how much variance is actually accounted for by the regression line, as opposed to just using the mean of y. All right. Essentially, what this means is it's always going to the r squared is always going to be a range of 0.00 to 1.00. So if all the values here lined up on the regression line perfectly, your r squared value would be 1. Right, and say that 100% of the variation is accounted for by the regression line. But in this model, only about 65% of the variance is accounted for by the regression line. I'm not saying that's a good value or a bad value, but that's the value that you have, okay? It's an ideal value, let's put it that way, for the most part, all right? Here, when you come down a little bit more, the next one you want to really focus on is the F value, okay, the F test. And it's significant. This is a bivariate regression model, right? And so it's only got these two variables. When you have a multiple regression model, you're going to have 5, 6, 7, 8 variables in there that you might be accounting for, more than just days in rehab. You might have it disaggregated by gender, a variable for gender, a variable for age to account for age, a variable for, prior offenses, or a variable for, education level. And all these things might be in the model itself. You can always look at your F-test here, and what that's telling you is that at least one of the slopes in the regression model is going to be significant, all right? And that's pretty much what it's telling you. And we have t-tests to look at this as well for each individual slope, all right? So this is accounting, it's a holistic test, and it's really accounting for all the slope values within the regression model, all right? So you know that the F-test is significant at the 0.05 range, so it gives us further evidence to look at the actual individual t-test, all right? Essentially is what you want to do. Here, the intercept this is the value, the expected value of the regression line when all the other independent variables in the model are set to 0. All right. So what we know is for days spent in rehab for this sample here that approximately all the individuals are going to use marijuana 17.3 times per year when they don't go to rehab whatsoever. All right. The standard error is the variation. Y'all, we talked about standard errors previously. I'm not too interested in that at this point in time. The T statistics is significant, and this has the upper and lower bounds. That's what Excel places here for you. Okay, but even more interestingly, perhaps, however, is the coefficient day spent rehab. Okay, so for every day spent in rehab, we know that marijuana use decreases by 0.3. Okay, and this value is significant because our T statistic falls outside the critical region, and the value occurs more than 95 times out of 100. In fact, it's more than 99 times 100 because it's less than 0.01. Right, and that's an interesting value as well. And that's superficially how you would want to interpret it. Okay. I also had a printout here, and I kind of want y'all to look at that. When we clicked, when I ran the regression model and had the plot, and I clicked that plot line, it printed out this graph as well. So here you can go here, and you can kind of mess around with it a little, but you can see the trend line, and you want to look predicted days using marijuana 1 year afterwards. Okay. And this is essentially the same graph that I have above here, the same scatter plot that I have above here. All right, and you can see the trend line, you can see the variables here. It starts at 10 for here, all right, and it goes all the way down, and you see 60 gets down below. All right, now obviously you can't use less than 0 days using marijuana. It's impossible to do that, but you know, the statistics that underlie it are sound, and this can be proved. Okay, this can be proved. The regression model itself, the regression equation, can be proved. So essentially, I want y'all to look at that and be able to interpret this R squared, the F test, and tell me what this coefficient value is. And this is what a line is. This is the slope value, essentially, what coefficient is, okay? And your T statistic and your P value. Now, within this regression model here, this bivariate regression model, there's a number of assumptions that have to be adhered to, that have to be met for this to be true, okay? For this to be adequate. And within all multiple regression models, your dependent variable has to be a continuous variable, okay? And by continuous, I mean either a ratio variable, which what we have here, okay? There's a 0, there's a true 0 that exists, or it has to be an interval variable, okay? It cannot be nominal, and it cannot be ordinal, where you have things ranked ordered, okay? Nominal being like gender, or you know, race or something like that. All right, that is not an efficient dependent variable, and it cannot be utilized in a regression model. There are other types of advanced models that do account for that, and you will want to use that when not every dependent variable is going to be continuous. It's not always going to be a ratio variable or an interval level variable. All right, it's important that y'all understand that when y'all look at these things. All right. For example, a logistic regression model. It accounts for a dichotomous variable, accounts for a nominal variable, and that would be a different dependent variable. And say, for example, you want to look at recidivism. Yes, either a yes or no type of question, okay? Or did you make an arrest or did you not make an arrest, right? Did you pass or fail? As far as recidivism is concerned, people want to look at that. They look at and analyze, how many delinquent peers an individual hangs out with, what their prior record involves. How long were they incarcerated? Did they go to rehab? All these different factors that might be somebody might want to look at. The relationship, if those factors do exist, right? Does education help? Did they get a job? Does that influence recidivism rates? All these other factors that might be accounted for. We're not going to go too that way with it. I want y'all to just understand the assumptions of a bivariate regression model, okay? And I'll have a link for y'all to look through. And essentially for this week, that's what I want y'all to do. Type this up on a Word document, interpret these results, interpret the R-squared, interpret the F-test, interpret the intercept, interpret the coefficient for days spent rehab as well as the t-tests and the p-value, all right? And hopefully y'all have a good basic understanding of what this means. And hopefully you can see that. Hopefully you can see that, you know, as days spent in rehabilitation increase, as you go from 0 here, you know, up to 60 here, the likelihood of using marijuana decreases, right, over time. And you can see the trend there, all right? And how much does it decrease? Well, if people spend 0 days in rehabilitation, their average marijuana use is 17.25 days of using marijuana, right, out of a year. All right, but for each day that they spend in rehabilitation, that decreases by 0.3. All right, and you can see that occurring over time, and that's really how this all breaks down. And that's the most basic, simplistic look at bivariate regression model or a simple regression model. Okay, it does get a lot more complex. I don't want y'all to get too overwhelmed by it all, but at this point, really what I want from y'all is to be able to interpret these things, okay? And going forward, I mean, this is the baseline. If y'all need to use more advanced tools, you can certainly look at multiple regression models or logistic regression models, okay? Now, those are a couple, two of the bigger statistical analysis that people with even PhDs, that's a lot of them will stop right there, right? Because we've already covered chi-squares, ANOVAs, t-tests, and those types of things, which are very useful. And a lot of people will integrate that into the research to some degree, right? As far as y'all are concerned, you know, this is a good start and a good end, okay? So hopefully this video helps out. Hopefully I didn't get you too confused with everything. And I'll type it up and throw it on the you know, the weekly module that I give out to y'all. But overall, it's been great having y'all in the class this year. And you know, let me know if y'all got any questions or concerns going forward with this stuff. I will attach a link to a page that talks about the assumptions. And it's important that you always understand the assumptions for any statistical test, okay? Because if anything's going to get you in trouble when you're trying to run these things, it's not understanding the assumptions. And this is beyond me. This is, you know, if y'all are going somewhere and trying to do this analysis and you're talking to somebody who actually knows, like in depth, that spend a lot of time. If you don't know the assumptions of a test and you're just going out there willy-nilly, you could get your feelings hurt. Let's put it that way. I know from experience. Not necessarily my feelings got hurt, but you know, people get snooty about statistics because we borrow it and we chop them all up in social sciences to some degree because there's so much error involved in our measures and the way we look at things and the way we apply mathematical concepts to what's going on, right, to reality. But we have to test it in some empirical fashion, and this takes away the, oh, I think rehab works, or, oh, I think this program's effective at reducing recidivism, you know, or whatever, you know, or whatever we want to test. We just as long as you understand what you're doing, understand the assumptions that underlie it, and the results, and you're interpreting them correctly, you know, you have something to fall back on. And you know, all right, that's about it. Well, I'll talk to y'all soon. I'll send out emails, and y'all be good. All right.